In question 4 of this series, where we balance chemical equations, we're expected to write an equation for the combustion of gaseous ethane, which has the chemical formula C2H6, which combines with gaseous oxygen to form carbon dioxide and water vapor. So let's write down the chemical equation. We have C2H6 plus O2, and this yields CO2, gas plus H2O, water vapor. The state of all 4 of these compounds is gas. And I'll represent that by putting a G beside its subscript. Just as in question 3, what we want to do is write down the atoms on both sides of this equation. Now, what you have on the left side, you'll also have on the right side. So we have C, H, and O. The same thing on the right side. Let's do a little bit of counting. We have 2 carbons, 6 hydrogen atoms, and 2 oxygen atoms. Here we have 3 oxygen because we have 2 here and 1 here, 2 hydrogens, and 1 carbon. My suggestion to you is if you have a combustion reaction and you're balancing its chemical equation, you want to start with the carbons. So I'll try to balance out the C's. We have 2 here and 1 here. I'll multiply this by 2, and we end up with 2 carbons. And now the number of oxygens has been altered. We went from 3 to 5 because 2 times 2 is 4 plus 1, and that's 5. Next, I'll try to balance out the hydrogens. Notice that I'm leaving the oxygens as the last element. So I want to make this 2 into a 6, and I can easily do that by multiplying by 3. This becomes a 6. We have 3 oxygens plus 4, that's 7. We have to somehow make this 2 into a 7 because the C's are the same and the H's are the same. They're balanced. But this 2 and this 7, there's a discrepancy. So what I can do is multiply this O2 molecule by 3.5. And I know your teacher probably has forbid you of using coefficients that are decimal, but it's a necessary evil here. Take a look at what I mean. I'll multiply this part right here by 3.5 because 3.5 times 2 gives me 7. So technically we have balanced this chemical equation, although, like I mentioned, you cannot have 0.5 or half of a molecule. It doesn't make sense. So if you run into a situation like this, you want to change 3.5 into fraction form. 3.5 as a fraction is 3.5, and that's a mixed fraction. We want to make it into improper, where we don't have this 3.5. Instead, we'll have 2 times 3 plus 1. 2 times 3 is 6, plus 1 is 7. We have 7 over 2. So 7 over 2 is the same thing as 3.5 and 3.5. I'll replace 3.5 with 7 over 2. Notice what I did there. And what this fraction is telling me is that I need to multiply the whole equation by the denominator of this fraction, this 2. So if I multiply this by 2, I need to multiply this by 2. And multiplying 7 over 2 by 2 makes it just 7. This becomes a 4, and this becomes a 6. Notice that all of our coefficients, the numbers in front of the chemicals, are whole numbers, and that's exactly what we need. If you do a count right now of the atoms, the left side and the right side will be balanced. The take-home message here is that if you use decimal numbers, such as 3.5, remember that you can multiply it by 2 and it becomes whole numbers as you see here. So anytime you see 0.5, for example in question 3, we had 6.5, we multiplied everything by 2 and it turned out to be whole numbers. And there you have it. That is how to balance chemical equations. In the next 2 videos to come, I'll show you how to balance chemical equations where compounds contain polyatomic ions. Hope to see you soon.